what must be true all the time about any kind of situation like this? Any kind of situation like this. Things I can call people randomly. All right, so Sal, what is true about every situation in this chapter? No matter what the problem is, no matter what it says, this thing must be true. What's that? There's energy. Yeah, I think you could say that. So yeah, I think that's a true statement. Vivian, can you think of anything else? What's that? Okay, there. So Sal's statement was correct. It's true. But unfortunately, it doesn't let us figure out what's going on here. Because whenever something breaks into two pieces, that is just like a collision, an inelastic collision. You know how like two pieces come together and stick? That's an inelastic collision. Well, if one piece explodes and becomes two, that's also an inelastic collision, but opposite, which means energy is not conserved. There is energy, so Sal was correct. There is energy here, but it's not conserved. But momentum is conserved, and that's the key for this problem. Momentum is conserved. So write out your momentum statement about what happens before this thing pops apart. So before that thing pops apart, what's the momentum statement? Let's see. Eric. Sorry, say that again? Okay, now what we're going to write over here is we're going to say, what is the momentum of the system before the pop, before it breaks apart? Okay, before it breaks apart. So Eric is using the momentum equation, but Kevin, Ton, before this breaks apart, how many pieces are there? One. Okay, so if we use, did you say equals or plus? Okay, we can't say equals yet because equals means before and after the event. Do you see the difference? One is before anything happens, and before it breaks apart, and the other is after it breaks apart. One is PI is before the collision, PF is after the collision. Do you see where I'm going with that? I is always before the event in question. F is after the event in question. So for PI here, Kevin's told us that there's only one thing, so Sally, what should I write? MV. Now, do I just put MV like this? If I do, what does that M represent, Bowen? Sorry? Is it just MA? Is MA or MB? Ah, thank you. That was excellent. MA plus B, so I could not trick Bowen, right? Does this make sense to everyone? Because it's stuck together, right? It hasn't broken apart yet. Now, of course, we can use MA, VA final, plus MB, VB final. And this is actually VB final. Now, what is this V, Vx, right here? Let's see. Christy, before I told you, anytime you see this, what are you supposed to do? Crack it. And when I crack it, what two things do I get? Yeah, what are those two things? What would you call them? Okay, so she's going to take us this way and give us the hard answer, which is nice. It's good to see people doing that. V sine theta and V... Oh, okay, good. That's the easy answer. Vx and Vy. Those are the easy answers. So do you see that this Vx is equal to that Vx up there? Okay, not because I labeled them Vx and therefore they're equal. It's because what happens to Vx through this whole problem, Joan? What is true about Vx from the beginning to the end? Oh, but from the beginning, excuse me, from the beginning to the top of the projectile motion. For an average, if I kick a soccer ball, boom, I kick it, it flies. What is true about Vx the entire time? It is constant. Why, Tim? Why isn't, you know how y changes, right? Like when I kick it, y is pointing up. Then y goes to 0, then y increases and comes back down. But how come Vx doesn't change? And what is there in the y that there is not in the x? There you go, okay? The fact that there's no acceleration in the x is the reason that Joan is correct in saying that Vx doesn't change. So this is Vx. So I get ma plus mb times v cosine theta equals ma va final plus mb vb final. Now do the algebra and finish per second. Now, that's only part of the problem, right? So if now 2 meters per second. Does that make sense to you? So half the trip is getting there at this. And they wanted to know how far it is from the launcher or what?
Yeah,
Okay, so they want x. All right, so all we have to do now is find the time it takes to get to the top, and then find the time it takes to get to the bottom. Does this make sense to anyone? Yes, no? Now, here's the question. If these two velocities are different, will the times to get to the top and the bottom be the same? Let me see. The time it takes, time is v minus v0 all over a. And when you do this, you'll get the time, plug it in, and get there. Be ready for a quiz tomorrow. Yeah. This becomes 60 and Vy was sine 60, right? That's actually negative over negative 10 meters per second squared. The sine of 60 is 0.8, so 0.8 times that is 48. Say it's like 52 or something, so this one plugged in times 5.2. And this is plus 57.2 times 5.2, and that's the total distance.